All right, guys, welcome to the derivative rules summary notes. It's going to be pretty quick. Just want to go through some basic things. So we're going to review what average rate is, what instantaneous rate is. We're going to remind you of what the derivative rules are. I'll show you some resources that I have for you guys to help you memorize all those as you get ready for your AP exam. And also, we'll quickly review implicit differentiation. This video is meant to be just a quick touch and go, not meant to take too long, just to get you guys ready for your practice. So here we go. Let's start by talking about average rate of change versus instantaneous rate of change. Okay, now average rate of change is when you're talking about a function and you are going from point A to point B. We'll call this point over here A, f of A. And then we'll call the other point over here B, f of B. Oops. All right. And so the average rate of change is basically the slope of the secant line. So the average rate of change is the slope of a secant line. And that's basically just a line that you would get by connecting the beginning point to the ending point. And the way that you calculate slope is you just do y2 minus y1 over x2 minus x1. And that tells you the average rate of change over the interval. Now let's talk about the instantaneous rate of change. The instantaneous rate of change is a slope at a specific point. So we'll put a point right here. We'll call it C, f of C. And an instantaneous rate of change is the slope of your function at that one point, which is going to be the slope of a tangent line. So tangent line is a line that grazes your function at a single point. Instead of going through 2 points like a secant line, the tangent line is one that grazes your function at a single point. And the slope of a tangent line is found by doing something known as the derivative. So if you wanted to find the slope at that point, it would be f prime of c. And so that's the difference between average rate of change and instantaneous rate of change. And both of those are going to involve, a lot of times the questions you'll be asked about these is to find the equations of the secant line or of the tangent line. If you ever want to find those equations, you're going to use this little formula right here, which is called the point slope formula. And you use that anytime they ask for the equation of a secant line or for a tangent line. The one caveat being that the slope is going to be this if you're talking about an average rate of change, whereas it'll be this if you're talking about an instantaneous rate of change. So whatever you put in for m is going to be one of these two things, depending on whether you're talking about a secant line or a tangent line. So there's that. Go ahead and move on to our next topic here. Now, the next thing I want to talk with you guys about is the main point of the chapter, which is talking about the tons of derivative rules that we have. This is a good time for me to reference our resources that I'm providing for you guys on Google Classes. I'm providing for you guys two things, flashcards and then a handout of all the derivative rules. I'll show those to you now. So these will be up on Google Classroom, but first of all, you have the derivative rules reference sheet. This is one way that you can kind of just see all the different derivative rules that we've learned. I've got them here for you. If you just want to look one up, like the quotient rule, boom, you can find the derivative right next to it. This tells you what the function looks like originally. This is what the derivative of that function looks like. And I've got them categorized by type over here. So that's your derivative rules reference sheet. We also have the derivative flashcards. And it's not just the derivative rules, but it's also other things in Unit 1 that we talked about. But the way that this is set up is this first sheet here is set A, that's your front, and then the next the next sheet is called back set A. For these ones here, these are the answers to these questions here. So if you were to print this sheet out front, like on double-sided, basically what would happen, the answer to this question would be this one here, and it should, I've tried to set it up so they line up perfectly so you actually just have pre-printed flashcards ready to go. Now, if you don't know how to make your printer do front to back printing, then you could just print this out, literally take the second page, flip it over, and glue it to the first page, and then cut them out, and you'll have instant flashcards. You don't have to use this. I would highly encourage you guys to use it, but there's a lot of just different rules on here and whatnot to help you guys memorize all the facts. So these are all the things that you would want to have committed to memory from Unit 1, and I would encourage you guys to use that. Those are your resources. There's one other topic I want to get to before I end my quick little review with you guys, and that's finding the derivative of an implicit function. An implicit function is a function that looks like this, where the y's and x's are all mixed up together in the equation. And it's a 4-step process. It could be a little bit tedious. On the worksheet that we're going to be going through to practice derivatives, there's a couple of different examples of these. But basically, the first thing that you're going to do is you're going to find the derivative of everything. So if I wanted to find the derivative of this, I would just go ahead and I'm going to put a d over dx right here. And I'm going to take the derivative of every one of these pieces. So that would be the first step I would take. So this would become 4x. This would become 3. This would become 8y. And then this would become 0. But for step 2, anytime the bottom variable, which is x, doesn't match the expressions variable y, kind of like here and here, then that means we're going to have to put a y prime next to it after we're done. So you just take the derivative like normal, but anytime this variable doesn't match the variable down here, you put a prime next to it. In this case, we had an x, which matches this, so we don't do that. The next thing you're going to do is you're going to move all the y primes to one side. So for instance, I might add this 3y to the other side here. And then after that, we move on to the next step, which is to get the y prime by itself. And in this case, you would have to factor out the y prime and then divide. Now, that's as far as I'm going to go with the quick little review here. This is not intended to be like a fully worked out example. I just wanted to bring the steps to life for you a little bit. But this is another good thing. I don't know if I put this on any of the flashcards, but this might be a good flashcard to make if you have trouble remembering these steps. That's basically how you'll be finding the derivative of an implicit function. But beyond that, I'm going to stop the video here, and you guys are welcome to start up your worksheet. I've given you a video where I go through every single problem on that worksheet. You're not intended to watch that whole video. Really just fast forward to the ones that you need help with. But the goal there would be to make sure you're going through the ones that you do need help with so that you're ready for your AP exam. All right? Hope that was helpful. Talk to you later.